WHONET training course, Module 3, Data Entry. There are two common ways to enter data into WHONET. First of all, manual data entry. You can manually enter data from paper records into the WHONET desktop application. There is also a new web application for data entry in development. Secondly, you can import data with Backlink. If you already have a computer system for managing your microbiology results, you can usually use Backlink to import your existing data. This avoids the need for double data entry. Backlink is automatically installed when you install WHONET. The data could be from a laboratory information system, a laboratory instrument such as Microscan, Phoenix, or Vitek, or other spreadsheet or database software such as Excel or Access. Backlink will be covered in a separate training course. In this module, we will cover data entry in 5 sections. A. Create a new data file. B. Entering and editing a data file. C. Opening an existing data file. D. The generation of clinical reports. Section E provides a few brief comments about Backlink, which will be covered in a different training course. When you open WHONET, you will see this screen. Select your laboratory and then click on Open Laboratory in order to proceed with data entry or data analysis. This will bring you to the main WHONET screen. I will click on Data Entry, and then I will click on New Data File. WHONET will then ask me to provide a file name and a file location. By default, data will be saved on the local C drive in the WHONET data folder, but you can change this to a different location. For example, you can choose a file location on a network server or a cloud server to facilitate data sharing with other laboratory staff or with other departments in the organization, such as the pharmacy. For the file name, WHONET is proposing a name with the country code, the laboratory code, and the year. For example, WHO TST 2024. WHONET uses a data structure called SQLite. After you confirm the file name, you can click on Save. This will bring you to a blank data entry form, and you will see the name of the new file indicated at the top of the screen, WHO Test 2024 SQLite. Section B, how do I enter and edit data? In the data entry form, you will see a number of questions. In the first question, origin, you indicate whether the sample comes from a human, animal, food, or environmental origin. You can then enter patient, location, and specimen details, followed by the organism and antibiotic results, as well as other information at the bottom of the screen. In the first question, origin, you have the options of human, animal, food, and environment. If I choose human, I will see the questions listed here at the top: first name, last name, sex, date of birth, etc. Under animal, WHONET requests the animal species, the animal type, and the market category. If I select food, I can indicate that this is a hamburger from chicken. I can indicate the type of food, which is meat, as well as the brand, for example, McDonald's. Under environment, you can enter the identification number of the sample. We can then proceed to enter the location details. For human isolates, this would include cardiology, medicine, inpatient, and a date of admission. For animal isolates, I can enter the name of the farm and the name of the state. I can enter similar information for food and environmental samples. Regarding different kinds of specimens, WHONET will present different lists depending on the sector. On the left, you see the different sample types from humans and animals. The two lists are almost the same. In the middle, you see the different food categories, and on the right, different types of environmental samples. You can then proceed to enter organism results. Here I have entered Staphylococcus aureus with the code SAU. I have also indicated that the organism is positive for the tests for beta-lactamase, MRSA, and inducible clindamycin resistance. For antibiotic panel, WHONET has automatically selected Staphylococcus aureus. On this screen, we can see how to use the search box. On the left, you see a list of all of the codes available to you, such as Acinetobacter baumannii and Bacteroides fragilis. In the right, you can see that I have typed Staph AUR in the search box. This permits WHONET to filter the organism list containing these letters: Staphylococcus aureus, Staphylococcus aureus subspecies aureus, and Staphylococcus auricularis. This example also highlights the use of synonyms in WHONET. The official name of this organism is Staphylococcus aureus subspecies aureus, but the common name is simply Staphylococcus aureus. Both use the same code, SAU. I can now proceed to enter antibiotic results. At the top, I see that the antibiotic panel is set to all antibiotics, and a large number of antibiotics is displayed. However, if I enter Staphylococcus aureus as the organism, WHONET now displays a much shorter list. Specifically, WHONET is showing the list of antibiotics that you have to find in antibiotic panels in laboratory configuration. This was presented in Module 2 of this course. Antibiotic results. You have a choice. You can enter the test measurements, such as the zone diameter in disk diffusion testing or the MIC value. Or you can enter the test interpretations, such as resistant, intermediate, or susceptible. We highly recommend the entry of test measurements. In the top example, you see a measurement of 6 millimeters for sulfoxetine, which is resistant, and 23 millimeters for chloramphenicol, which is susceptible. At the bottom, you see that it is possible to enter the letters R, I, and S. However, we recommend the entry of measurements. The software also permits you to enter results for MIC and e-test data. For example, on this slide, I have entered 1 microgram per milliliter for cefotaxime, greater than 4 for penicillin, and less than or equal to 1 for vancomycin. For SXT, which is trimethoprim sulfamethoxazole, I have entered 1 microgram per milliliter, which is the concentration of trimethoprim in this antibiotic combination. For vancomycin, the interpretation is susceptible, and for SXT, the interpretation is intermediate. For cefotaxime, you see 2 interpretations, S and I. For penicillin, you see 3 interpretations, R, and R. The reason for multiple interpretations is described on the next screen. Multiple interpretations. For some bacteria and antibiotics, there are different clinical breakpoints depending on the disease, for example, meningitis and urinary tract infections. There can also be different breakpoints depending on the animal species. In the lower left, you see an example with Streptococcus pneumonia. There are 2 different breakpoints depending on whether the person has meningitis or not. There is also an example for Escherichia coli and ampicillin, showing that there are different clinical breakpoints depending on whether the patient is human or a cat. It is useful to keep in mind that the purpose of CLSI and UCAST clinical breakpoints is not the detection of resistance genes, but instead it is the prediction of clinical outcomes. For example, if a patient has an infection with an isolate of Streptococcus pneumonia with a low degree of resistance, this can still be fatal for a patient with meningitis. But there may be a good clinical outcome if the patient has an ear infection or pneumonia where higher concentrations of antibiotic can be achieved. Test measurements. We strongly recommend the entry of test measurements such as zone diameters and MIC values. The measurements are required for accurate reporting to clinicians. Also, the interpretive criteria can change over time, and the data analyst needs the measurements in order to compare new statistics with older statistics. Measurements permit an assessment of test quality, and they facilitate recognition of microbial subpopulations and mechanisms of resistance. You can see an example of this in the lower left, where you see Escherichia coli susceptible to ampicillin to the right of the red vertical lines. And you see 2 different kinds of resistant bacteria to the left. The highly resistant bacteria appear at 6 millimeters, while the moderately resistant bacteria appear at 11 and 12 millimeters, suggestive of a different mechanism of resistance. In the lower right, you see the same distribution of test results, but utilizing the clinical breakpoints for soft tissue infections in cats. We can see that the population of bacteria appearing at 11 and 12 millimeters would be considered to be intermediate for the treatment of sick cats, but resistant for the treatment of sick human patients. The most common test interpretations are R, I, and S. The letter R represents resistant and S represents susceptible. For decades, the letter I was used to represent intermediate results, and this is still true when utilizing CLSI methods. However, a few years ago, UCAST revised the breakpoints and the definition so that for laboratories using UCAST method, I now means susceptible with increased exposure. You may also note some additional interpretations in WHONET. SDD is a CLSI category, meaning susceptible, dose-dependent. It is similar to the UCAST I category. NS means non-susceptible. This is a category used by CLSI where there is a definitive susceptible category, but there are insufficient data to establish an R category. This category is often utilized when resistance is rare and there are little clinical data for evaluation. A question mark means simply that there are no breakpoints for this organism and antibiotic. You may occasionally see interpretations of S question mark and R question mark. These are explained on the next slide. The categories of S question mark and R question mark only appear for off-scale MIC data, such as MIC less than or equal to 2, when the MIC breakpoint does not correspond to the breakpoints. For example, if the breakpoints for an antibiotic are S less than or equal to 1 and R greater than or equal to 4, and if there is an isolate where the user enters an MIC less than or equal to 2, there is ambiguity. The less than or equal to symbol would suggest that the organism is susceptible. However, an MIC equal to 2 would be intermediate. This discordance between an MIC value and the breakpoints may happen because of a typing mistake by the user, but more commonly, the reason is because of a change in the breakpoints. For example, older MIC panels were designed with imipenem concentrations that corresponded to the old CLSI breakpoint of S less than or equal to 4. But in 2010, CLSI changed the susceptible breakpoint to S less than or equal to 1, which led to difficulty in interpreting results from the older test panels. In this situation, WHONET will give the interpretation of S question mark with the idea that most bacteria that were previously considered to be susceptible by the older breakpoints would probably also be susceptible with the new breakpoints. But since we do not know the exact MIC, we cannot be certain. Slide 23. As you enter your antibiotic results, you may also see a number of alerts. WHONET offers microbiology alerts for findings of clinical and public health importance, such as important species, important resistance, quality control, or therapy comment. The alerts can help to notify laboratory staff about important findings or results that may suggest an error in the organism identification or the antimicrobial susceptibility test result. You can also define your own alerts in laboratory configuration. Slide 24, microbiology alert example. For example, in this screen, the isolate of Escherichia coli generates an alert for imipenem resistance as a high priority alert, and ceftriaxone resistance as a medium priority alert. There is also a quality alert because the isolate is susceptible to ampicillin, but resistant to amoxicillin clavulanic acid. On the data entry screen, you will see several options in the upper right. In this module, we will discuss Save Isolate, View Database, and Print. After you have entered the information for the isolate, you click on Save Isolate to save the result to the database. The options are slightly different depending on whether you are saving results for a sample of human, animal, food, or environmental origin. For example, if you have a human sample, you are given 3 options: save the isolate, save the isolate and continue with the same specimen, and save the isolate and continue with the same patient. The second and third options are useful if you have multiple organisms from the same sample or multiple samples from the same patient. For animals, the options are save the isolate and continue with the same specimen, save the isolate and continue with the same animal, or save the isolate and continue with the same location. This last option would be useful if you are entering results from several animals from the same farm. For this particular isolate, there are no microbiology alerts, and I will click on OK to save the isolate. On this screen, we can see a summary of the alerts for a different isolate. This isolate has one alert for carbapenem resistance and also a quality control alert. These alerts are valuable in identifying possible typing mistakes. They are also valuable in alerting the data entry person to results of high importance that may require further confirmation and notification to health authorities. WHONET also permits you to enter the results for quality control specimens. For example, if I enter ATCC 25922 as the identification number, WHONET automatically recognizes this as a quality control specimen, and the organism is Escherichia coli. In the lower right, you can see that I have entered a zone diameter of 30 millimeters for amikacin, and WHONET is alerting me that this is outside of the expected quality control range of 19 to 26 millimeters. When you click on View Database, WHONET will show you a list of all results that you have entered for this file. From this screen, you can click on Edit Isolate or Edit Table to make corrections or to add additional information. You can use Delete to remove isolates, and you can use Find to search for isolates, for example, using the patient's name or a specimen number. You can click on Print to print out clinical reports that can be shared with clinicians. The clinical reports will be discussed later in this module. When you finish reviewing the database, click on Continue to return to the data entry screen. When you are ready to leave the data entry program, click on Exit. We will now move on to Section C. How do we open an existing data file? I have now returned to the WHONET main menu. I click on the menu for data entry. There are two options for opening a data file that already exists. At the bottom of the menu on the left, WHONET shows me a list of the data files that I have opened most recently. If I see the name of the file that I would like to open on this list, I click on it. Or if I do not see the file, then I select Open Data File, as you can see below right. If you click on Open Data File, WHONET will ask you to find the file, and then you can click on Open. You have now opened your data file. The data entry screen is blank, so you can begin to enter additional results into this file. I can click on View Database in order to see the results that I have previously entered. I can use the options that we have seen previously: Edit Table, Edit Isolate, Delete, Find, Print, and Continue. Section D, Clinical Reports. We have already seen an option called Print in two places, on the main data entry form and also in the View Database area. I will now click on Print. On the screen, you can see the option for printing clinical reports that can be shared with clinicians and specimen collectors. You can also click on Modify Clinical Report if you wish to modify the content and formatting of the report. If I click on Print, WHONET will ask me to confirm the details and to select a printer. You may select a true printer, or you can select PDF. If you select PDF, WHONET will ask you to provide a name and location of the new file that you want to create. And then you can share this PDF file with clinicians and specimen collectors. If I click on Modify Clinical Report, I can see options that permit me to improve the formatting and content of the clinical report. I can click on Report Header to change the information that appears at the top of the report. I can click on Report Footer to change the information that appears at the bottom of the report. I can also click on Data Fields to change the data content that will appear in the middle of the report. I have clicked on Report Header, and it allows me to introduce additional information at the top of the report. By default, WHONET will indicate the name of the laboratory, but I can also enter the address and phone number. I can change also the font and the position of the information, as I can see in the lower right. If I click on Report Footer, I can change the details at the bottom of the report. By default, WHONET will include a timestamp for the printout. I can also include a signature line and the name of the laboratory director. I can also change the font and the position of the information, as you can see in the below right. If I click on Data Fields, I can change the content in the middle of the report. On the left, you see all of the fields available, and on the right, you can indicate which fields should be included in the report. In this example, you will see the patient's identification number and the patient's name appear in the top left of the clinical report, while the patient's location and specimen date will appear in the top right. These will be followed by the microbiology results, such as organism, beta-lactamase, and antibiotic results. You can use the arrow buttons on the screen to include additional fields in the report, such as physician name and gram stain. You can click on Move Up and Move Down to change the sequence of the fields. You can click on Font to change the font style or the font size. When you've finished making modifications, click on OK to return to the previous screen. On the screen, you can click on Print Example to see what your clinical report will look like, as we can see below. Finally, I have a few comments about the backlink software. Most laboratories in the medium and high resource world already have computer systems for managing their microbiology data, and also many in low resource settings. These can be simple desktop systems such as Excel or Access, or they could be laboratory instruments such as Vitek, Markoscan, or BD Phoenix, or they can be a laboratory information system. These diverse systems are an obstacle because they are not directly compatible. They use different codes, database structures, and languages, but they are also an opportunity. The laboratory data have already been stored in an electronic database. The goal of Backlink is converting data from these existing incompatible systems into common WHONET files, which should avoid the need for double data entry. Backlink will be covered in a separate training course. Thank you for watching Module 3. Next, Module 4, Introduction to Data Analysis.